Hello folks, today we'll understand star and snowflake schema, and we'll understand this through the one of the example. In our example, we'll take a retail example. So suppose ABC is a company that sells electronics product, right? They have a store across the US in different geographic location. You as a customer, you live in the USA, suppose in some of the state. So you are going to search nearby location for the ABC. You will go that store. You will look iPad if you like gray or maybe black color. It depends on what is your preference, right? You will take that product. You will go to the register or terminal, and you are going to pay either through the credit card, debit card, any approved method. And if you want, you can apply the, if you have the discount, you will apply a discount, or you want to apply a coupon or maybe a gift card, you can apply that. Once you pay that, you are coming home, right? Same way, same day, suppose that is Sunday, some other location, some other user is purchasing some other item, maybe he's purchasing the iPad or some other item. He will go to store, he will do the same kind of activity. So in US, all the 100 store, they will have sales in every day. So here the business user are interested to see each store how they are performing and what kind of product mostly these stores are selling, right? So they want to that kind of data, and maybe they want to look the product description also. So for that, IT department, what the IT department will do, they will collect the information from different systems. They will put those data into tables, and the top of that they will do analysis, and that analysis report, maybe Power BI or Tableau, depends on what kind of report business users are interested. This kind of report they will provide to business users, right? So in this example, if we talk about the simple example, we have five different tables, right? So let's talk about the first is the customer, which is very important. We have customer, we have store, we have product, we have calendar, and sales, which is adding a business value, right? In customer, let's say customer ID, this is our primary key. Customer first name, customer middle name, customer last name, customer phone number, customer email, customer address, customer card, etc. We have the product. Product ID is your primary key. Product description, Q, product color, etc. Let's take about the store. We have a store ID, that's this is primary key. Store number, store zip code, store city, store state, store phone number. These are the store number. Same way calendar, we have calendar ID, primary key, calendar date, calendar month, calendar year, quarter, quarter 1, quarter 2, quarter 3, right? Now coming on the sales ID, this is the primary key, and I'm storing all the customer, product, store and calendar primary key as foreign key in this sales table. So I will have customer ID, foreign key, product ID as a foreign key, store ID as foreign key, calendar ID as foreign key. I will have sales amount, I will have sales product count, sales date, these are my sales information, so on. So now this our example. Let's say business user are interested how much sales is happening with the store, each store. So we'll have there is a relationship between sales and store, right? And business users are interested to see the product description. Let's say for example in our case iPad, we sold the iPad. They want to see, right, particular queue. Let's say for example you are storing the queue here. Particular queue, how much, what is the name of the product, and you need a relationship with the product team. Someone is looking for the email ID, so email ID can come from the customer information, right? So these are your lookup table. If you see customer, this is your lookup or dimension table. This is your, this is again your dimension. This is your dimension or lookup, right? So sales is your fact, which is containing the business value, right? And these dimension, these are your lookup. So if a scenario comes where your fact table is surrounded by the lookup tables, in center you have the fact which is adding the business value, the business is caring about that value, and which is surrounded by the your lookup table. If this kind of architecture, then it's a star schema. So star schema in generally what happen, right? If you have the less data and you don't want to add complexity on joining the tables, you want to make your simple architecture and you don't want to be very complex query, and storage is not a concern. Let's say for example in these days, right, if you see the S3 or the blob, most of the cloud provider are giving very cheaper storage. You want to utilize that and you want to make simple design, then in this case you are to going to use the star schema, right? But sometimes what happens, there are scenarios where you are taking some licensing storage or software, right, where this storage is a costly, and same time you want to make more normalized kind of design, right? So what, let's see here example. Let's say for example employee, right? If I take example of the employee here, right, employee can also purchase item from the store. So employee, let's say employee ID is the primary key, employee first name, employee last name, employee date of birth, employee department, suppose, right? So this is an employee who is also getting item from the ABC store, right? And this is we are talking about the ABC store or organization, right? So now if business users are interested, see how many employees are purchasing from their store, suppose, if that kind of need comes, right? Let's remove this one. So then employee and sales table has to join. So how they will join? This employee ID will store as a foreign key in the sales table, right? Now there is another table, that is department table. Department table has department ID, the primary key, department name, right? Department code. This is again your lookup or dimension table, right? So then employee will have a relationship with the, because this department, right? This is here as a foreign key. It will have the relationship with the department. You are adding one more layer. If you see, you are adding one more layer. You have the fact table. Top of that, you have one lookup table. This is your lookup table employee. And then you have another lookup table, which is department, right? So another layer you are adding. So if you are adding that kind of complexity, and this is, it's not a complexity, you are adding one more layer of the lookup table, then this is your snowflake schema. So let's say, for example, business users are interested to see particular department how much product these employee are purchasing. So then what you will do, you have a join between sales, employee and department. It's a little bit complex compared to the past what we have discussed. If you are looking for a little bit complex kind of join, then this kind of schema we say snowflake. So if you see the star schema, which has star fact is in the central, which has the business value, is surrounded by the lookup tables, right? But in snowflake, if you see, you have lookup table. That lookup is table is connected by the another lookup table. There may be one or more lookup table that they are connected. And if this kind of scenario comes, it's your purely a snowflake schema. Okay, so let's understand this through the PPT. Next slide I will go, right? So if you see, this is the we are talking about fact, which is in central, which is the business value, right, surrounded by the dimension table or lookup tables, where we have the data, lookup data, dimension data. If this kind of architecture we are following, this kind of design schema we are following, this is your star schema. Again, we are talking here with the example, right? So we have connected different tables. If you see in this example, right? So we have product, which is connecting with the fact. Product ID is the primary key, which is in foreign key in the fact table, right? And we have time and product. All these tables are interconnected with the fact table. That is task. Snowflake. Snowflake, we have more layer. We have fact, which is surrounded by the lookup tables, but again those lookup tables are connected with the different dimension table. So we have more layers. If someone is looking for the information which is going to the nth layer of the dimension, then he has to write a complex kind of join. So this fits. If you have right now, if you have you are looking really normalized data where storage is a costly, then you are following the snowflake schema, right? So I hope these concept will be clear. Thank you very much for watching.